So today we're going to be talking about square roots. We're going to be simplifying them. So if you have your notes, you can look at them. All right, so today we're going to be simplifying square roots. A square root is simplified if they cannot be divided by a perfect square. You might ask, what is a perfect square? A perfect square is a number that when you take the square root of it, you do not get a decimal. Okay? So for example, some of our perfect squares, the smallest perfect square is 1. Because if you do the square root of 1, you just get 1. Okay? What's the next smallest square root? Or perfect square? 4. Because when you do the square root of 4, you get 2. Right? What's the next perfect square? 9. The next one? 16. The next one? 25. 36. 49. How are you getting these? Yeah, just multiply by the next number. So that's 7 times 7. So next would be 8 times 8. 64. Hold on. So he found it on the wall. He found it on the wall. He doesn't know them off his head. Okay. 81, then 100, then 121. That's 11 times 11. Then 12 times 12?
144.
13 times 13?
169.
14 times 14?
196.
15 times 15? 16 times 16? Oh, that one's not on the wall. We don't know.
What is the calculator? 256.
256. What would come next? 289. 17 times 17. So you could keep going forever and ever and ever. I probably won't give you anything that would be bigger than any of these. Okay? So a square root is simplified if it cannot be divided by any of these numbers. So when I look at this first one, the square root of 72, okay, and I put the list of perfect squares, it's there again on the screen, so we can see it. It's also up on the whiteboards in here. The square root of 72 is simplified if it cannot be divided by anything in that list. Can it be divided by any numbers in that list?
Yes.
Which one?
4. 9.
9. 9 times what? 9 times 8. So I'm going to rewrite this as 9 times 8. That's still the square root of 72. I just wrote it differently. There's a little time symbol in there. It's kind of hard to see. Okay? So now what we're going to do is I'm going to take the square root of 9. So what's going to happen is I'm going to take out the 9 out of the square root. What is the square root of 9?
3.
3. Okay? So then the 3 is outside. What's left inside? 8. So now we have to look at the 8. Can the 8 be divided by anything in my perfect square list? 4. Okay? So I'm going to do the same thing. I'm going to take the 3 square root of, what am I going to change the 8 into? 4 times 2. Because 4 times 2 is 8. Okay? So then the 4 is going to come out of the square root and turn into a what? Square root of 4 is 2. It multiplies to anything that's already on the outside. Okay, so now outside I have 2 times 3, which is 6. And left in the inside, what do I have? 2. So then look at the 2. Can the 2 be divided by anything in this list? 1. When you get to 1, you're done. So my answer is 6 square roots of 2.
We should do that every time.
You do have to do that every time. However, I'm going to give you a helpful hint. Okay? Helpful hint. Now, don't erase everything on your page, but I'm going to erase everything on my page. Well, I guess I didn't need to erase the answer, but I started now. Okay? When you look at your numbers, if you can find the biggest thing that goes into 72, you're going to have a lot less work. If you had noticed that 72 can be rewritten as 36 times 2, we could have immediately gone to, all right, oops, I didn't get the 2 written down. You could have immediately said, okay, that 6 is going to come out. What's the square root of 36?
6.
So then I'd have 6. What's left inside? And I would be done. So if you can find the biggest number that divides in, then you only have to do it one time. Does that make sense? So try to find the biggest number is the goal, okay? It's like a game, like a puzzle, okay? All right, the next one, square root of 48. So again, I want the biggest number from my list over here. 24 and 2 are neither one of those numbers are in my list. 16 times what? 16 times 3. All right, 16 and 3. The 16 is my perfect square. So when it comes out, what does it turn into?
4.
A 4. So I end up with 4 square roots. What's left inside? 3. Look at my list over here. Is there anything over here that can go into 3 other than 1? No, so that means I'm done. 4 square roots of 3. Questions? Okay. Square root of 90. Look at your perfect squares. What square root goes into 90? Or what perfect square goes into 90? 9. 9 times what? 9 times 10. When the 9 comes out, what does it turn into?
3.
A 3. So I end up with 3 square roots of 10. Then check the 10. Is there anything in my list that can be divided by 10? No, just the 1, right? Can go into 10. So that means I'm done. All right, look at the next one. 3 square roots of 20. It's okay that you've got something outside. Just leave it alone for now. The 20. Is there anything in my list that divides into 20? Which one? 4 times what? 4. That's a 4. Times 5. When the 4 comes out, what does it turn into? So on the outside, we multiply these together. 2 times 3 is 6. And left inside is 5. Can the 5 be divided by anything other than the 1? No, so that means we're done.
How do you turn the 4 into a 2?
The square root of 4 is 2. All we're doing when we take it out is we're square rooting it. Because that's how you get something out from under the square root. Okay? All right, the next one, 7 square roots of 18. Again, the 7, we just ignore. We leave that outside till later. The 18, can it be divided by anything in my list?
9.
By 9. So 9 times what? 2. When the 9 comes out, what does it become? A 3. What do I have on the outside? 21. What's left on the inside? 2. Can the square root of 2 be divided by anything over here? No. So I end up with just 21 square roots of 2. Okay? 2 square roots of 100. 50 is not in my list. 25, so 2 square roots of 25 times what?
4.
So when I do that, the 25 comes out as a what? 5, so 5 times, but wait. The 4 is over here. It's a perfect square. What does it come out as? So it also gets multiplied. What's 2 times 5?
10.
Times 2.
20.
And there's nothing left under my square root, so that means that's just my answer. Now, we made that a lot harder than it needed to be because
100 is already numbered.
square root of 100 is what? 10. So you could have just done 2 times 10. You know.
So late.
All right, adding and subtracting square roots. In order to add square roots, they have to have the same number under the root symbol. So just like when you're doing variables, don't write this down, but just like if I was doing 2x plus 3y, or sorry, 3, not y, 3x. 2x plus 3x would be what? 5x, right? But if I had 2x plus 3y, could we do that? No, okay? So it works the same way when we do square roots. They have to be the same square root in order to be able to combine them. So if I look, I have a square root of 6, just one of them, because there's nothing in front of it, so I know it's just one square root of 6. And I'm adding 2 square roots of 6 to that. So if I have one of them plus 2 of them, how many of them do I have? 3 of them, so 3 square roots of 6. Then you just kind of want to look at the square root of 6. Is there anything over here in my list that can go into the 6? No, so we're done. Okay? All right, the next one, 18 square root of 3 minus 2 square root of 3. So I've got 18 of them minus 2 of them. How many square roots of 3 do I have? 16. Square root of 3. Then I look at my list. Can I simplify the square root of 3? No, nothing divides into it. So that means we're done.
That's it?
That's it.
Wow.
Look at the next one. 4 square roots of 5 plus 2 square roots of 5. That gives me how many square roots of 5? 6 square roots of 5.
Oh, wow.
Can the square root of 5 be simplified?
No.
No. All right, the last one in this section, 5 square root of 10 minus 3 square roots of 10 gives me
2 square roots
2
of 10.
square roots of 10. Very good.
Gosh.
Easy peasy. Adding and subtracting is really easy because you either can do it because they're the same square root, or you can't. And if you can't, you just say I'm done.
Also take your video off.
Okay. All right, look at the next one, multiplying square roots. Coefficients, okay? Coefficients are the number that are outside the square root. You multiply them together. So if there's outside the square root, they just get multiplied, okay? And then numbers under the square root are also just multiplied together. So outside ones go together, inside ones go together. They don't play well. So if one's outside, one's inside, you can't multiply them together.
So is that 25 squared?
Kind of, almost.
How's that? 5?
Square root of 5 times square root of 5 is the square root of 5 times 5 is 25. Is that what you said?
Yeah.
I'm saying that it's 5.
Yeah. So the square root of 25 is just 5. Kind of a fun thing, anytime you multiply a square root by itself, the square root cancels and goes away. So if you did square root of 3 times square root of 3, you'd get 3. If you did square root of 7 times square root of 7, you'd get 7. Okay? That only works if you repeat the square root when you're multiplying. Okay? The next one, square root of 10 times square root of 2 is 20. Square root of 20. So now look, can I simplify that? See, it says here's check for simplification.
Yes.
Which perfect square goes into my 4? How many times? 5 times. When the 4 comes out, what does it turn into?
2.
So I'm left with 2 square roots of 5. Check over here again. Is there anything that goes into 5?
No, because it's not a number.
No, so then we're done. 2 square roots of 5. You said no because it's what?
Square root. No, because it's an odd number.
Well, odd numbers, look, 9's an odd number.
Wait, no, not because it's an odd number.
It's a prime number, right? Yeah, it's a prime number. All right, the next one, 2 square roots of 2 times 3 square roots of 12. So again, the outside numbers we multiply together. So 2 times 3 is 6. And then the inside numbers we multiply together. 2 times 12 is 24. Then we check over on the side. Is there anything over here that can go into the 24?
Yes.
4. How many times?
6.
So we change this to a 4 times 6. When the 4 comes out, it becomes a 2. So on the outside, I have what? 12. And on the inside, I have 6. So then we look over here. Is there anything that I can do with the 6? No. So that means 12 square roots of 6 is my answer. Okay? 7 square roots of 5 times 5 square roots of 2. So again, we start with our outside numbers. 7 times 5 is 35. Square roots of 10. And then I look over to this side. Is there any of these numbers that go into 10? No, so that means we're done. 35 square roots of 10. All right, let's talk about dividing. Dividing square roots. Root symbols, so your square root is not allowed to be in the denominator of a simplified square root. So what does that mean? It can't be where? In the denominator in the bottom, right? So if you have a square root in the denominator, you have to do what we call rationalizing. Okay, and it's just 2 steps, just 2. One is multiply the top and the bottom by the square root that's in the bottom. And then 2 is to simplify. Yay, easy peasy. All right, when I look at the first one, 5 over the square root of 2. So I said step 1, multiply the top and the bottom by the square root in the bottom. So I'm going to multiply the top by the square root of 2 and the bottom by the square root of 2. And so really we're multiplying by the fraction square root of 2 over square root of 2. Okay? Now, normally we say you can't do something to one side of the equals unless you do it to the other side, right? But look at what I'm doing. If you divide something over itself, like 4 over 4 is what? 1. 5 over 5 is 1. 8 over 8 is 1. So if you do the square root of 2 over the square root of 2, that's just 1. Okay? What happens when you multiply something by 1? It stays the same. So you're allowed to multiply by 1. We're just multiplying by a weird version of 1. Okay? Because look what happens when I multiply my numerator. 5 times the square root of 2, there's nothing I can do there because one's inside, one's outside. It just stays 5 square roots of 2. But then on the denominator, what happens here? What did I say happens if you multiply a square root by itself? The square root just cancels out. So what do I have in the denominator? Oh, look, I no longer have a square root in the denominator. Yay! So that's step 1. Step 2 is to simplify. All you have to do to simplify is check your square root. Can I simplify this square root? No. Then look at this fraction, 5 over 2. Can that fraction be simplified?
No.
Yes.
What would you simplify it to?
Oh my God.
No, so we're done, right? If you can't simplify the square root or the fraction, then you're done. My answer is 5 square roots of 2 over 2. Okay? All right, so remember, step 1, multiply the top and the bottom by what's in the bottom. So over here, I'm going to multiply the top by the square root of 3, so 3, and the bottom by the square root of 3. So when I multiply the top, square root of, or 27 times the square root of 3, I can't multiply them because one's in and one's out, so it just becomes 27 square roots of 3. What do I end up with on the bottom when I do square root of 3 times itself?
3.
Just a 3. So then I look at 2 things. I look at my square root. Can I simplify this?
No.
No, so then I look at my fraction, 27 over 3.
Yes.
Yeah, what's 27 divided by 3?
9.
It's just 9 over 1, or just 9. So this becomes 9 square roots of 3, and I'm done. If you leave it as 9 over 1, or 9 square roots of 3 over 1, that's okay. Okay? Again, the first thing we do, multiply by the square root in the bottom. So I'm going to multiply the top and the bottom by the square root of 3. Now, the top already has a square root of 3 in it. We've already practiced multiplying square roots together. You should know what we're doing. 4 square roots of 2 times the square root of 3 is 4 square roots of 6. And then square root of 3 times square root of 3 is 3. Look at your square root. Can I simplify this? No. Look at 4 over 3. Does that reduce?
No.
No, so that's my answer. 4 square roots of 6 over 3. Okay? What's the first thing I'm going to do on the next one?
Yeah.
Multiply where?
Square root of 3 by 15.
Where am I going to multiply by? The denominator and the numerator. Both of them by the square root of 3. So the top and the bottom by the square root of 3. What do I end up with in my numerator when I multiply here?
15 and 18.
15 square roots of 18. What do I end up with on the bottom? 3. Okay. Square root of 18. When I look at this, can I simplify this?
Yes.
Yes. What goes into 18 from my list over here? 9. So I'm going to rewrite this as 15 square roots. Oops, I forgot my 15. 15 square roots of 9 times what? 2 over 3. When the 9 comes out, what does it turn into? A 3, and it's multiplied to the 15. Okay, so 3 times 15? 45. What's left in my square root? All over 3. All right, so now if I look back at my square root, can I simplify the square root of 2? No. What about 45 over 3? Yes, what does that become? 15. Square roots of 2. Okay, and you might have seen that over here that this 3 would cancel with this 3, 15 square roots of 2. Okay, 15 square roots of 2 is my answer. Six square root of 3 over the square root of 2. What's the first thing I want to do? Multiply by the square root of 2. Where at? Numerator and denominator. Pass might be up there. Square root of 2 over the square root of 2. 6 square roots of 3 times the square root of 2 is 6 square roots of 6. What's in my denominator? 2. Then I look at my square root. Can I simplify the square root of 6? No. What about 6 over 2?
Yes.
What is 6 divided by 2?
3.
So 3 square roots of 6. All right, the next one, 3 square root of 6 over the square root of 2. What am I going to do? Multiply where? Numerator and denominator by what? Square root of 2. What do I end up with in my numerator? 3 square roots of 12 over 2. Very good. Look at your square root. Can I simplify 12?
Yes.
Yes, because what can it be divided by over here?
4.
By 4. So I'm going to change that to 3 square roots of 4 times what?
3.
Times 3 over 2. So all I did was change my square root of 12 to the square root of 4 times 3. When that 4 comes out, what does it turn into? 2, which would get multiplied to that 3. 2 times 3 is? Over 2. The 3, can I simplify the square root of 3? No. What about the 6 over 2?
Yes.
6 divided by 2 is what? 3. So 3 square roots of 3. All right. We're almost done. All right, equations with square roots. When I see x square roots of 3 equals 15, in an equation, there's really only 4 things we do, just different variations of them. We add, we subtract, we multiply, divide. When you see x square roots of 3, what do you think the x and the square root of 3 are doing? Are they adding, subtracting, multiplying, or dividing each other? Multiplying, right? Because if they were adding or subtracting, we'd see a minus or a plus. And if they were dividing, we'd see a division, a fraction bar, or division symbol or something. If we don't see anything, that means dividing. What's the opposite of division? Sorry, multiplying. What's the opposite of multiplying? Division. So in order to get rid of that square root of 3, I need to divide both sides by the square root of 3. Division, property of equality. When you do that on the left-hand side, your square root of 3 goes away. And so you just have x equals 15 over the square root of 3. Unfortunately, we're not allowed to have a square root in the denominator. So what do I need to do? Multiply the top and the bottom by square root of 3. So I multiply up here by the square root of 3, and I multiply down here by the square root of 3. What do I get in my numerator? 15 square roots of 3 over 3. So then look at your square root. Can I simplify this square root? No, it's square root of 3. There's nothing over here that goes into 3 other than 1. Can I simplify my fraction? Yes, 15 divided by 3 is 5. So this becomes just 5 square roots of 3. Okay. 3 more. Yes. Y square roots of 2 equals 6. How do I get the y by itself? Divide by the square root of 2. So my square root of 2's cancel on the left-hand side, leaving me with just y. On the other side, I have 6 over the square root of 2. I'm not allowed to leave a square root of 2 in a denominator, so I have to rationalize. So I multiply the top and the bottom by the square root of 2. What's in my numerator? 6 square roots of 2. What's in my denominator? 2. Does my square root simplify? No. Does my fraction simplify?
Yes.
6 over 2 is what?
3.
3. So 3 square roots of 2. Two more. All right, a square root of 2 equals 4 square root of 5. How do I get a by itself? Divide by square root of 2. So my square root of 2's cancel on the right-hand side, or on the left-hand side. On the right-hand side, I get a equals 4 square roots of 5 over the square root of 2. I can't leave a square root in the denominator, so what do I have to do? Times it, the top and the bottom by what? By square root of 2. What do I end up with in the numerator? The top.
4 square roots of 10.
Yes, perfect. 4 square roots of 10. And on the bottom? 2. All right, 2 things to check. The first one, my square root. The square root of 10, can that be simplified? No. 4 over 2, can that be reduced?
Yes.
Yes, 4 divided by 2 is 2. 2 square roots of 10. Okay? B square roots of 3 equal 8 square roots of 12. What do I do? Divide by the square root of 3. Very good. When I do that, on the left-hand side, my square root of 3's cancel, leaving me with just B.
Equals 8 square roots of 36.
Oh, hold on. We're missing some steps. We skipped some. 8 square root of 12 over square root of 3. And then we're going to rationalize. So we're going to multiply the top and the bottom by square root of 3. So now I have the 8 square roots of 36 over what's on the bottom? 3. Okay. Square root of 36, is there a number that goes into 36 from my list? Oh, 36. That's a perfect square. What is the square root of 36? 6. So that means this is really just 8 times 6 in the numerator over 3. What's 8 times 6? 48 divided by 3? 16. So my answer is just 16.
How'd you get the 36 to become 8 times 6?
Because it was, the 8 was already right here, right? And it's 8 times the square root of, we'll go with green. 8 times the square root of 36, but the square root of 36 is 6. So I just replaced it with what it equals. Okay? And then multiplied them together. Any other questions? All right.